in our previous videos on calculus, we looked at the definition of calculus, its application, and we dealt with the differentiation from first principle. And also, we dealt with the techniques of differentiation. But today, we want to look at so many calculations on what we have dealt with before. To be precise, we want to solve 15 questions on differentiation. And before we move on, you remember what we did in our previous videos. We said that we have two types of calculus. It could be differentiation or integration. And I put it to you guys that slope or gradient is also called derivative, and that is dy ds, as regards talking about y and x. And I proved the formula that also if I have a Cartesian of y against x, and I have an angle theta here, so we're able to see that the gradient is also change in y over what? Change in x. And we're able to see that if you use your SOHCAHTOA very well, your trig ratio, opposite over adjacent will give us tan. And we're able to look at that a gradient or slope is also the tangent of angles to the horizontal. But integration is the area under the curve. We're going to be looking at integration later in this course. My name is Olanipekun Oluwagbenga, and I'll be taking you through on how to solve some questions using the techniques of differentiation we have learned. To be precise, 15 solid questions. I will be increasing it until a day you're going to solve 100 questions, maybe for 6 hours. Follow me as I take you through all these. Before we proceed, there are some basics that you have to know that we have done before. Now, the first one is this. If I differentiate ax raised to power n for the first one, the n will come down as we have known before, and that becomes a n x, and you must always subtract 1 from the index, and we have this. Also, if I differentiate sine x, you will get cos x. Please take note of this. We are going to be using them very soon. If I differentiate cos x, I'll be getting minus sine x. If I differentiate tan x, I'll be getting sec square x. If I differentiate sec x, I'll be getting sec x tan x. And if I differentiate cosec x, I'll be getting what? Minus cosec s tan x. And if I differentiate cot x, I'll be getting minus cosec square x. Now look at the way it's going. If I differentiate e raised to power x, it's very common, I'll be getting e raised to power x again. Now look at this. If I differentiate ln s, I'll be getting 1 over x. Ln x is the same thing as log s to base e. You'll be getting 1 over x too. Now, if I differentiate sine inverse of x, I'll be getting this 1 over the square root of 1 minus x squared. In the same vein, if I differentiate cos inverse of x, I'll be getting minus over square root minus 1, negative 1, rather, divided by square root of 1 minus x squared. And finally, for this course, if I differentiate tan inverse of x, I'll be getting 1 over 1 minus x squared. Please note all these things that we are looking at today. We're going to be using it to solve questions soon. Now, look at this. I will quickly start with the basis of what we have. If I have y equals, look at this, 5x squared, just the basis. We have not started the 15th question yet. This will surely give me for dy dx of this, the square will come down. That becomes 5 times 2, and that will be 10. We've done this before. X, then you subtract 1 from the top, and that will be 1. And that gives us what? 10x. Look at this again. If I have y equals 20x raised to power 3, so it means dy dx in this case will be equals to what? The 3 will come down, 20 times 3 will give us 60x. So you subtract 1 from the top, and that will be 3 minus 1. And that gives us what? 60x raised to power 2. Now look at this. If I have v equals 2t squared minus 4t plus 8. Now look at this. dv dt in this case, you differentiate each one of them. That becomes what? 4t. Remember, the 2 will come down, minus, I have 1 here. So if that one comes down, negative 4 times 1 give us negative 4. Then t, 1 minus 1, that gives us 0. Then if we differentiate a constant without a variable, that gives us 0. Please note that. And that gives us 4t. Remember, anything raised by 0 is 1. And that gives us minus 4 in this case. So we have this. Now, the first question from the 15 questions we're going to be solving. So let's start. The first question, number 1. Now, the first question is this. Y equals, I have them here, pen down, 2x plus 5. Then we have 3x minus 6. That is the first one. Now, looking at this, I'll be giving you a shortcut in solving this and the long method in solving this as well. So let's continue. The first thing you do is to note which checklist are you going to use here. I have a function and I have a function. Because they are multiplying each other, we are going to use what? The product rule. And the product rule says if I have this something like this, same as saying y equals uv. So you call this u and you call this v. Good. So u equals 2x plus 5 such that du dx, look at that now, du dx, if we differentiate 2x, what will you get? 2. And if I differentiate 5, I will be getting 0. Very good. Then I have v for the other side to be what? 3x minus 6. If I differentiate dv dx here, this one will give me what? 3. Very good. And if we differentiate negative 6, we get 0. Now, the formula for product rule is now dy dx equals, you leave u, the first one, you differentiate the second one. We're going to use the sharp way without writing all this formula. Then you sum it with, differentiate the second one, then you leave the second one constant. I'm leaving v now, meaning I will differentiate u. So let's put the value there. So that my u is 2x plus 5. Very good. Look at that. Into dv ds is 3. Then we have plus v, 3x minus 6. Then we have du dx is 2. Such that we're going to be getting what now? That becomes 3 times 2x. That is 6x. Plus 5 times 3, 15. Then we have plus 3x times 6. That will be 6x still. Then we have minus 18. Now, what do you think the final answer will be? Final answer will now be equals to 6x plus 6x will give us 12x. Good. Then 15 minus 18 will give us minus 3. And that is dy dx. 12x minus 3. So it quickly means that dy dx is now 12x minus 3. So what we are trying to do there is differentiate one, leave one constant, and that is what we call product rule. That's the first one. Now, question 2. If y equals 4x minus 8 over 2x plus 5. Look at this. Now, this is division. I have a function that is 4x minus 8. I have another function 2x plus 5. And they are dividing each other. We call it quotient rule. So I can have this as u over v. Very good. And what do we have in that case? That means I have u as 4x minus 8. So du dx, please follow me, will give us, if we differentiate 4x, what you get? You get 4. If we differentiate negative 8, you get 0. Good. And v equals 2x plus 5. So dv dx will give us, differentiate is that gives us 2, right? Very good. And so the law for quotient rule says that you will have to leave the second one, the denominator, differentiate the numerator, then negate it from leaving the numerator, differentiate the denominator, then what do you have in a denominator? Then you square the denominator. Now, what do we get as our v? Our v was 2x plus 5, right? Good. Then times du dx, we got 4. Good. Minus u was 4x minus 8. Good. And my dv dx that we got was what? 2. That means if you differentiate the denominator, you can pause the video and go back to see. And my denominator was 2x plus 5. Be very careful with this negative. So we have 2x times 4, that is 8x. 5 plus 4 will give us 20. Minus, look at that, minus 4x times 2. Negative 4x times 2 will give us negative 8x. Negative 2 times negative 8 will give us plus 16. Check that very well. Yeah, that is correct. Then everything over 2x plus 5. Remember, square. Remember, that is square here. Yeah. Very good. That is what we have in the formula. So my final answer will now be equals to, let's put the answer here. That will now be 8x minus 8x, that is 0. So 20 plus 16, that will give us 36. So we have 36, everything over the denominator, 2x plus 5 all squared. And that is question 2. Remember, anytime you have division, that is quotient rule. And what does that mean? You differentiate the numerator times the denominator minus differentiate the denominator times the numerator all over the square of the denominator. It's getting more interesting. Question 3. More interesting. Question 3 is y equals 2x. I'll be giving you a shortcut in solving this when we are done with the long method. Look at this. What do you think this technique is? We've done it before. This is function of function or chain rule. So anytime you have something like this, then we have like ax plus b, then we have raised to power something this way. That is function of function or chain rule. And I will be going with that now. So let's go. Now, the first thing you do is to say, let u be the inside, and that is 2x minus 8. So we have u, we have x. So you say du dx will give us what? 2. If we differentiate 2x, we get 2. If we differentiate negative 8, we get 0. That is good. The next thing is we now have y will now be what? Everything was u. Do you remember that? So we have u raised to power 2. Therefore, dy du. Look at that. I have y and I have u. That will be dy du. Remember, the 2 will come down, and that will be 2u. 2 minus 1, 1. Therefore, dy dx, look at the chain now, will now be equals to du dx, the chain, times dy du, times dy du. Let's put the value there. What is my du dx? That was 2 times dy du, 2u. And that gives us what? 4u. And remember, what is my u? 2x minus 8, and that becomes 4 into 2x minus 8. And then we can expand it to become 8x minus 32. Now let's see, we are going to get the same answer using the shortcut method. Now the shortcut method is this, or for question 3. Question 3 is why? Because we are going to be using it anytime we have function or function in a combined question. Look at this. It's very easy as well. Straight away, dy dx will help us this way. The 2 will come down like we have in our general formula. The 2 will come down. Look at that. Differentiate the inside. If we differentiate the inside, what you're going to get? You get 2. Good. Write everything back. I'll come again with that. Then subtract 1. 2 minus 1, that will give us 1. Again, the 2 will come down. Differentiate the inside, you get 2. Then write everything back. 2 minus 1, we get 1. So we have 4 into 8x minus, 4 2 times 2 is 4. Then we have 2x, minus 8. Very good. So it's correct. 4 times 2x, that is 8x minus 32. That corresponds to what we got before. 8 minus 32, 8 minus 32. So they are the same. Very good. So let's move on. Question 4. Yeah, it's getting more interesting. Question 4. Question 4. We are still going to 15. Question 4. Now look at this. Y equals cos 3x. Remember the basis I gave you. You differentiate cos x. What are we going to get? Very good, minus sin x. But in this case, it is now having a coefficient of 3. So it can no longer just be minus 3x. So we have to do something with that. And this is also function of function that we just did now. And what do we do here? The first thing you do is to say, I'll be showing you the shortcut of this as well. Let u be 3x such that du dx equals what? 3. Good. And therefore, y will now be equals to cos u such that dy du, if we differentiate cos, that becomes what? Minus sin u. Very good. That is it. So that we can now move on to put the final answer. So we have dy dx equals du dx. Remember that chain rule, times dy du. What is my du dx? Du dx was 3 times dy du, that is minus sin u. Now that will be what? Negative 3 sine. Remember, our u was 3x, so that is 3x. Now look at the shortcut method, dy dx. Shortcut method, dy dx. Look at that. Differentiate this, you get 3, right? Differentiate cos, you get negative sine. Then put what? 3x, and that is it. And that is synonymous with this as well. Very good. Okay, question 5. We have 10 more to go. Question 5. Good. Question 5. Now, question 5 is like that as well. Y equals tan 8x. So this one is trying to show us if we know the derivative of tan. What do you think we are going to do here as well? You see, say let u equals 8x, right? Therefore, du dx will now gives us what? 8. Very good. Then we go back to now say y equals tan u. Look at that now. Now, from our basis, if we differentiate tan u, what will we get? Dy du. Very good. That becomes sec square u. Such that our dy dx will now be equals to du dx times dy du. Such that du dx 8 times dy du sec square u. Now let's put the value of u. So that becomes 8 sec square u was 8x. So you put your 8x, and that is it. The sharp method, or the shortcuts, dy dx, look at it again here. Straightforward. Differentiate this. That will be 8, right? Differentiate tan sec square, then put your value back, 8x. Look at it. The same answer. Yeah, we are moving. Question 6. Very good. Question 6. Question 6. We are moving now. Look at this. Y equals ln 4x. Yes, we are moving as well. It's still function of function. I'm trying to expose you to more ways of asking function of function. If you have this, you also say let u be 4x. So that means we're going to be having du dx. And du dx will give us what? 4. Very good. Such that y will now be what? Ln u. So we are going to be having dy du. So dy du in this case becomes what? Remember, if we differentiate ln x, that is 1 over x. So ln u becomes what? 1 over u. Such that dy dx, using the same formula, will now be du dx times dy du. Very good. And what is my du dx? That is 4 times 1 over u. I'll be giving you the shortcut as well here. That becomes 4 over u. And what is our u? 4x. And if you cut 4 here 1, 4 here 1, and that is 1 over x. Now, the shortcut method on this, what do we have for the short method? For the short method, dy dx, look at that now, will now be equals to, differentiate these, that is 4, over, anytime you are differentiating ln over, then write what you have there back. That is it. It's as simple as that. And that is 1 over x still is equal to this. Yeah, it's getting more interesting. Question 7. We are moving it together. Question 7. Very good. Look at this. Y equals to e raised by 3x. Yeah. This is also function of function. You can see that we have different ways of asking function of function or chain rule. So the same thing again, you say let u be 3x. I'll be showing you the shortcut on this as well, such that du dx equals what? 3, right? And my y becomes raised power u. And remember, if you differentiate e raised power x, you get e raised power x back. In the same vein, dy du will also give us e raised power u back, such that dy dx will give us du dx times dy du. And that will be 3e raised power u. And that will be what? 3e. And my u is 3x. And that is it. Now, I'll be showing you the shortcut on this as well. Look at the shortcut here. The shortcut is as straightforward as ABC. dy dx as well. Differentiate the top. That will give us 3. Write everything back. And it's as simple as that. They are still the same thing. Good. Question 8. Question 8. We are moving it together. Question 8. Okay. Yes, it's getting more interesting. Y equals 4e raised power 3x. Now, I'll be using the sharp method as we move on. So there's no need to be taking you through long method anymore, since you know that now. So dy dx will now be equal to what? Look at it. You write your 4 is a constant. Differentiate the top. That will give us what? 3, right? Then we have e. Write it back, 3x. And that gives us what? 12e raised power 3x. And that is it. Question 9. Now, what question 9 trying to tell us here? Question 9, we have y equals sine 4x plus 3. Good. In the same way, that becomes what? Dy dx. Differentiate the inside. That gives us 4, right? Differentiate sine. That is cos. Then write everything back. Yeah, so you have known that now. You have known that now. Good. So we can move on to question 10. Now, question 10 has a combination of everything that we are looking at. Question 10. Now look at question 10. If y equals, 3e, that is the reason why you must know how to solve individual. So this is product rule having function of function. Can you see that? Now, what does product rule say? So, dy dx for product rule says that what? Let's go together now. Leave the first one, 3e raised power 2x. Differentiate the second one. And if you differentiate cos 8a, you'll be getting what? Differentiate 8, you get differentiate 8 as you get what? 8. Good. Then differentiate cos, you get minus sine. That is it. We have dealt with that. Remember, it's product rule plus. Now put the second one back, cos 8x. Now differentiate the first one, and that becomes what? 3 will be there. 3. Differentiate the upper one, we have 2. Then we have what? E raised power 2x. Good. So I will repeat that again. Leave the first one. Differentiate the second one. Differentiate 8x, you get 8. Differentiate cos, you get negative sine x. Now leave the second one. Differentiate the first one. We have 3. Differentiate 2x, you get 2, then write everything back. So let's multiply out. That becomes 3 times 8 minus 24 e raised power 2x sine x. Good. 3 times 2 is 6 plus 6 e raised power 2x cos 8x. Good. This is the answer. But something is common there. 6 is common. Then e raised power 2x is common. We're going to be having 6 in 24 minus 4. Good. Then e raised power 2x we go. Then sine x. Good. Then we have what here? Plus cos 8x. Very good. Question 10 gone. Question 11. We have 4 more to go. Question 11. And what is question 11 saying? Look at that. Y equals ln 3x. Product rule again. Cos 2x. Good. Product rule. Remember, you leave the first one, differentiate the second one, plus differentiate the first one, leave the second one. So let's do the same. So that will now be the y dx will give us what here? Leave the first one, ln 3x. Good. Differentiate the second one, differentiate 2x, you get 2. Differentiate cos, you get negative sine, then 2x. We have dealt with that. Then plus. Differentiate ln 3x, remember, 3 over 3x straight. Is that okay? Then we have times cos 2x. Yes, that's good. So we move on from there. And that will now be negative 2 sine 2x ln 3x. 3 cancel 3. So we have what here? Cos 2x over x. Remember there's a plus sign here. So I think this will give the answer. Then nothing is common here. So we have this as our answer. Very good. Look at that very well. That gives us the answer there. Question 12. Now look at 12. Is giving us this. We have y equals sec 2x. Then we have sine 5x. Sec 2x sine 5x. It's still product rule as well. So we have to do something here as well. The y dx. Leave the first one. Sec 2x. Good. Times, differentiate this one. Remember, 5. Differentiate sine cos. Then we have 5x. Good. Plus, differentiate this now. Leave your 2. Differentiate sec. What are we going to get? Sec x tan x. Good. That will be sec 2x tan 2x, right? Then times sine 5x. Please look at that very well. I differentiated sine 2x. Differentiate 2x, you get 2. If you differentiate sine, you differentiate sec, you get sec tan. Then that is sec 2x times 2x. Then times sine 5x, right? Good. And that will now be all together will be 5 cos 5x sec 2x plus 2 sine 5x sec 2x tan 2x, right? What is common? Nothing is common, so we can say that that will be the answer in this case as well. Question 13. Question 13. 13. 2 more to go. Good. Now look at 13. Y equals tan 3x minus 1, then log 4x minus a to base e. Remember that a log anything to base e is same as ln. And we are going to be using the same thing again. This is still product rule. So that dy dx will be equals to, leave the first one constant, differentiate the second one. Remember, that will be what? 4x. If you differentiate 4x minus a, you get 4, then over everything you have. Good. Then plus, write this, then times, if you differentiate this, if you differentiate tan, you get sec square. So what do you do first? Times, if you differentiate 3x, you get 3. Then we have sec square 3x minus 1, right? Minus 1. Do you have anything common here? Let's see. Nothing is common. Let's check again. If you differentiate, leave this. Differentiate that, you get 4 over 4x minus 8. Leave this, then differentiate this. We have 3 sec square 3x minus 1. There is nothing that is common, so we leave it that way as the answer. Number 14. Yeah, we have spent 36 minutes for this. Number 14. 14, we have one more to go. Good. Now look at this, question 14. It says that if you have y equals 4x squared plus 4x3 minus 8x4. Find the cube y over d x cube. That's the question. That means we are going to differentiate 3 times, right? And that will now be what? Look at that. And that will be y dy dx. Yeah, in this case will be what? Let's go together. Differentiator becomes 8x, good, plus 12x squared minus 32s cubed, right? Now another one, that is we are doing it to the third derivative degree. Differentiate again, we get 8, we get 24x, and we are going to be getting what here now? Minus 3 times 2, we are getting 6, 3 times 3, we are getting 9. Then subtract what? 2 from that. 3 minus 1, that is 2. Then finally, based on what we have to calculate now, d cube y over ds cube. That will be equals to, if you differentiate 8, you get 0. If you differentiate 24x, you get 24. Negative 2 will come down. 2 times 6, 12. Then 9 times 2, 18, plus 1, 19. 2 minus 1. So we have d cube y over ds cube. Now look at the final one, which is the ultimate of all. Look at the question. It says, question 15. If y equals 2 cos x plus 3 sin x minus cos 2x, show that d squared y over dx squared, second derivative, plus y is equals to 3 cos 2x. So the first thing to do is to tell us where you are coming from. Is it from the left hand side or from the right hand side? This is to show. So let's come from the left hand side. I think that will be better. So from left hand side, good. So from left hand side, what we're going to do, let's calculate the square y over the x square. Remember that we need to do dy, you need to do dy dx first. Dy dx. And dy dx will give us what? Differentiate cos, you get negative, then the constant 2, then sine x, good, is there. Then if you differentiate this one, that becomes plus 3 cos x, good. Differentiate this, if you differentiate cos, you get negative. Negative times negative, that is plus, then 2 sine. You can see the usefulness of the shortcut method now. So that will be our first dy dx. Then we need the squared y over the x squared, right? If we differentiate this, what we're going to get? Minus 2 cos x. Differentiate this, we get minus 3 sine x, right? Differentiate this again, you differentiate 2, you get 2. 2 times 2, that becomes 4. Then we have cos 2x. So we have dealt with that. So let's put the square y over the x squared plus y. Good. So let's put them together. So this will give us the final answer. Remember, if you are new on this channel, please, I would like you to press the subscribe button, the like button, and press the notification bell so that you don't miss from any of our videos. Now, finally, the squared y all over the x squared plus y will now give us, let's put all those things there. We have negative 2 cos x, negative 3 sine x, plus 4 cos 2x, plus 2 cos x. That's what we got. Then we are now putting for y. Then y plus 3 sine x minus cos 2x. Now if you look at this very well, some of them we cancel out actually. Minus 2 cos x. What do we have that? Plus 2 cos x. There we go. Look at this again. Minus sine x plus sine x. So we are now left with what? 4 cos 2x minus cos 2x. And they are like terms. That is 3 cos 2x. So what do you notice there? Left hand side equals right hand side. So that is, we have shown it. Yeah, we have solved 15 questions in this minute, and we're able to solve all these questions based on the foundation I've given you in the past. So I would like you to pause the video every now and then to check what we have done. And if you are still new on this channel, please, I would like you to subscribe, press the notification bell to get more of our videos so that you don't miss from any. See you in the next video.